Okay, now we're going to talk about something that I actually find really enjoyable. It's a conjugate. A conjugate is the same binomial. And remember, if it's a binomial, that means there are two terms with opposite sign in the middle. So, for example, if I had the square root of x plus 7, the conjugate would be the square root of x minus 7. And these are really helpful. We're going to cover why. But first, we need to talk about how conjugates must be used to rationalize radical denominators containing two terms. The only way I can rationalize a denominator with two terms is by multiplying by the conjugate. So here I have I want to know what the conjugate of x minus square root of 2 is. That would be x plus root 2. And what's the conjugate of negative 2 plus the square root of x? Negative 2 minus the square root of x. Now, the reason these are helpful is found whenever I multiply. So let's go ahead and take this first conjugate and multiply by the conjugates. This is a double distribution, so x times x is x squared. X times negative 2 square root of negative 2. The square root of 2 times x. And then root 2 minus times the negative root 2 would be minus the square root of 4 or 2. These two middle terms cancel, and I'm left with square root of 2 minus 2. Now, the cool thing about conjugate is every time I multiply a conjugates together, those two middle terms will always cancel. So, if you recognize that, hey, this is two conjugates I'm going to multiply, you can skip multiplying those middle terms. So over here, I would have, these are two conjugates. So I know I can do negative 2 times negative 2 or 4. And then the square root of x times square root of x minus x. And this would be my product. Okay, if you forget that that's what conjugates do, it's not a big deal. Just double distribute them, use the box method, whatever you normally do to multiply binomials, and you'll still get the same answer.